Hello, welcome to helpyourmath.com. In this lecture, we're going to discuss about exponents. And this is part 1 of our lesson on exponents, and it's the introduction to the product rule. So we're going to learn about the laws of exponents and eventually how we evaluate negative exponents. So let's look at the properties of exponents. The figure here shows a square and a cube. So each of these sides is 1.5 centimeters. So a square, the area of the square is 1.5 squared. So that means it's to the second power. Where the cube, the volume of the cube is 1.5 times 1.5 times 1.5, which means it's to the third power or cubed. So because the area of the square is 1.5, we say that anything to the second power is x squared. And similarly, for our cube, where we say things are cubed if x is to the third power, and we call that x cubed. So exponents and the vocabulary associated with them are topics that we will study in this section. So let's see if you can do the following. So why don't you take out a pencil and paper and see if you can multiply x to the fifth power times x to the third power. Now don't worry if you can't, because we will learn about this in these lessons. So let's see how we can do this. And this would be, in this case, we multiply, and if you've learned it before, you know that if you multiply exponents, you add up the exponents, and that will give you x to the eighth. Now see if you have learned or remember how to do division. So if we divide y to the ninth divided by y to the fourth. So just see if you can do it or you remember how to do it. And also remember, if you don't, that's okay, because we're going to go over it or learn it in these lessons. Well, in the case of division, we're going to subtract 9 minus 4, here's where the 9 is, and minus 4. So 9 minus 4 will give us y to the fifth. And then finally, here we have an exponent, or a power to a power. And if you haven't learned it before, don't worry about it. We're going to learn it. And if you have, just see if you remember how to do it. When we have a power to a power, we multiply, so it's 3 times 2, and that will give you x to the sixth. So in our first example, what we looked at was a situation that used something called the product rule. And the product rule keep the same bases, and if the bases are the same, we add the exponents. So that means, notice that this is the base where the x's are. These are called the bases. And if they are the same, we can add the exponents. So that's m plus n, where we get that from here. For example, this just shows how it works. So here is x cubed, 1, 2, 3 x's. And x to the fourth, 1, 2, 3, 4 x's. So if we add those, this would be x cubed plus 4, 3 plus 4, and that would give us x to the seventh. So when you multiply powers, you add the exponents. So let's look at a few exercises. So here we have y to the seventh times y to the third. Well, as I said, you just add up when you have y is the same, y is the same. So that means we just have to add up these exponents. And of course, 7 plus 3 is equal to 10. So we get y to the 10th. for example number 5. Now, if you don't see an exponent here, we assume that that is 1. What this means is that this is a to the 10th, and this is a to the 1st, so that's 10 plus 1, which will give us a to the 11. For number 6, here we notice even though they're not letter bases, they're number bases, the bases have to be the same, and these two are the same, so the base is 2, so all we're going to do is add up the exponents as we did before and keep the base the same. There we have the 2 is our base because the 2's are the same, 2 plus 3, and that gives us 5, so finally we get 2 to the 5th. In example number 7, well, here we have an issue because we have x to the 5th and y to the 3rd. Now, there's an issue because our bases are different. So that means that we cannot simplify this any further. So that's important to note, and you must be very careful to make sure that when you're doing the product rule and you're adding up the exponents that your bases are the same. Number 8, well, here we have not just 2, we have 3 bases that are the same. So that will mean that we add up 7 plus 3 plus 6 because we have the 3 bases are exactly the same, so that means we get b to the 16. And then in example number 9, again, you want to be very careful of your bases because here we have x's and here we have y's. So we can add up our x's, 12 plus 6, and then our y's, 10 plus 4. So that means we have our x's add up to 18, so that's x to the 18th, meaning the power on our x's. And our y's, the power on our y's, add up to 14th, and we cannot simplify this any further. When we're multiplying a monomial by a monomial, we want to determine the sign, and then we want to multiply the coefficients, and then we want to multiply the letters by adding the exponents for like bases. So let's look at some examples to understand what these instructions mean. So let's look at example number 10. So here we have this particular problem. So why don't we work this out on the whiteboard and see how this is done in detail using these rules. In example number 10, we have negative 2 x to the 6th, y to the 4th, times 6x squared y cubed. So what I'm going to do to organize it, I'm going to put all my number terms in one bracket, 2, all my number parts there, 2. And I'm going to put my x's in another bracket, x6, x squared, so 2, and negative 2 and 6, x6, x squared, and then my y's, y to the 4th, y to the 3rd, y to the 4th, y to the 3rd. So I see that negative 2 times negative 6 is negative 12. And then I use my exponential property for this, so I add them, 2, and then my y, 4 plus 3, and that's going to be equal to negative 12 x to the 6th, y to the 7th. And now I have
multiplied my two monomial terms with exponents.
In reviewing what we just did on the whiteboard in example number 10, what we did is we collected up the coefficients, -2 times 6, so here are coefficients, here are x's, and we added up their exponents since it's multiplication, and our y's, and we added up our exponents, and then we put it together, and that's how we got our final answer. In example number 11, well, let's work this also out on the whiteboard in more detail.
In example number 11, I have the two monomials, -7, a cubed, b to the 8th, and then -4, a squared, b squared. So again, I'll put my numbers in one bracket, and I'll put my a's in another bracket, put my b's in another bracket, and now I'm going to use my product rule for these two, but I'll just use regular multiplication here. And I find -7 times -4 is positive 28. And then I use my product rule here where I have a, 3 plus 2, and then my product rule here for b, where I have 8 plus 2. So I finally get 28. A, 3 plus 2 is 5. And then 8 plus 2b is 10. And that's my final answer.
In reviewing what we just did on the whiteboard in number 11, here we have our coefficients. And remember that a negative times a negative is equal to positive. Here I have my a's, so I added up my exponents, and my b's, and I added up my exponents. So I got positive 28, and of course 3 plus 2 is 5, and 8 plus 2 is 10 for the b's power. In number 12, well, here we have a fraction, and yes, fractions do happen. So let's work this out on the whiteboard in more detail.
In number 12, I have the monomial 10xyz, and then I have 1/2 x squared z. Now, fractions happen. So even though there's a fraction there, you could still do the number multiplication. 10 times 1/2. So I put that in one bracket. Then I look for my x's. I have an x from here. I have an x from here and an x squared. And this is to the first power. And then I have one y. So I'll put a y here. And then I have two z's. So I have z, z. So now 10 times 1/2 is the same thing as saying 10 over 2. And 10 over 2 is equal to 5 because 2 goes into 10 5 times. So that means I will get 5. Now let's look at this. X. This x is 1. First power plus 2. And then y. Don't have to worry about it. And then the two z's are each to 1 power, so it's 1 plus 1 using our product rule. And now I have 5 x to the third, y, z to the 2, and I'll just write 5x cubed y z squared.
In reviewing what we just did on the whiteboard in example number 12, here I did my coefficients, and as you see, it's 10 over 2. That's what 10 times 1/2 means. And then I have my x's, and then my y's. I only have y to the first power. That's all I have here. And then I have my z's, and I have 2 of them, and all of them to the first power, so it's 1 plus 1. And then I put it together to get my final answer. In example number 13, well, we have now 3 monomials. So let's go over to the whiteboard and work this out in more detail.
In number 13, we have negative 2, 8 to x to the 8th, y. We have negative 3, x squared, z to the 3rd. We have negative 5, y cubed, z to the 7th. And what I'm going to do, as usual, I'm going to take, even though we have 3 different monomials, I'm going to take all my number terms and put that again in one bracket. Negative 2, negative 3, negative 5. And then I'm going to look at my x's, all my x's, and I'll put my x's in another bracket. X to the 8th, x squared. And then I will put my y's in still another bracket. 1 y here, no y's there, and a y cubed here. So I have y cubed. And then finally, I'll collect up all my z's. I have no z's here. I have z cubed here. And I have z to the 7th here. So now I'll start multiply. Well, here I have a negative 2 times a negative 3, and that will give me a positive 6. And then I have a positive 6 times a negative 5, and that'll give me a positive 30. Then for my next part, I have x 8 plus 2 using my product rule. And the next one here, I have y 1 plus 3. And finally, my z's, I have 3 plus 7. And then I'll carry the 30 down, and x 8 plus 2, well, that will give me x to the 10th. And then 1 plus 3, y to the 4th. And then finally, 7 plus 3, z to the 10th. And that's my final answer.
In reviewing what we just did on the whiteboard in number 13, as you see, we have the coefficients, so I gathered them up into coefficients, and a negative times a negative makes a positive, but then multiplied by another negative will make a negative. And then I took my x's and gathered up my x's and added the exponents, my y's and added the exponents, and my z's and added the exponents. I get as my final answer negative 30, x to the 10th, y to the 4th, z to the 10th. Welcome to part 2 of exponents. In this part, we're going to discuss the quotient rule. The quotient rule says that when we keep the bases the same, we subtract the exponents. So for example, if we have x to the m and x to the n, that means that x to the m is divided by x to the n, and that means we're going to subtract the exponents of x. Notice how the base of both of these is the same, and it's x. For example, the reason we can do this, so if we have 2 to the 6th power divided by 2 to the 3, so I have 6th power means 2 times 2 times 2 times 2 times 2 times 2, and 2 to the 3rd is 2 times 2 times 2, and then I can cancel out 3 of these 2 from the top, 3 from the bottom, and I put this 1 in here as a placeholder, and that means that I have 2 times 2 times 2, or 2 cubed, and this is essentially 1 because they're exactly the same. That's the same thing as saying 6 minus 3, which is also 2 cubed. And it just turns out that if we work that out, 2 cubed is 8. So here's just another example where we're using the variables instead of the 2's, and the same idea, as one can see, that in the end, instead of getting 2 cubed, you get x cubed. So when you divide powers, you subtract exponents. So let's look at some examples. In example number 14, we have x to the 15th over x to the 10th. And if you notice, our bases are the same, which is x. So that means we can subtract 15 minus 10, and that will give us x to the 5th. In example number 15, we have w to the 27th over w to the 9th. That means we subtract 27, the exponents 27 minus 9, in order to get w to the 18th. For number 16, we have a to the 9th over a to the 9th. Well, it turns out that 9 minus 9 gives us 0, so that's a to the 0. And if you haven't learned this, this is a very important thing to know, that any expression to the 0 power is always equal to 1. This is a very important thing to know, and that's something that will occur over and over and over again. In number 17, well, we have a to the 7th, b to the 4th, a to the 7th, b squared. Now let's go to the whiteboard and work this out in greater detail.
In number 17, we have a to the 7th, b to the 4th, over a to the 7th, b squared. So as usual, I'll put my a's in one bracket, a to the 7th, a to the 7th, and I'll put my b's in another bracket, b to the 4th, b squared, and then I will use my quotient rule. So I have, for the first one, a to the 7 minus 7. And then for my b's, I have b to the 4th minus 2. Now it turns out a to the 7 minus 7 is a to the 0. And b to the 4 minus 2 is b squared. And it turns out anything to a 0 power is equal to 1. So our a to the 0 is equal to 1, and then b squared. But we usually don't write the 1, just like when we have a silent E or something like that. We may write it, but we don't say it. But in this case, we see that it's there, and we know that that 1 is there, but we usually just write b squared.
When reviewing what we just did on the whiteboard, for example, number 17, we see that we collect the a's, and 7 minus 7 is 0, and the b's, 4 minus 2 is 2. And as we said, Anything to the 0 power is 1, so that gives us 1 times b squared, so that means it's just b squared. So remember, any expression raised to the 0 power is equal to 1. And this will come up many times and very often, so it's very important you understand this concept. When dividing a monomial by a monomial, we must first determine the sign, divide the coefficients, and divide the letters by subtracting the exponents for like bases. So why don't we do a few examples to understand what this means? So in example number 18, we have negative 24 times x to the 6th y to the 5th divided by negative 6 x to the 4th y squared. So why don't I go over to the whiteboard and work this out in detail first.
In example number 18, we have negative 24 x to the 6th y to the 5th divided by or over 6x to the 4th y squared. Now, as before, we'll put our numbers in one bracket, negative 24, negative 6, and we'll put our x's in another bracket, x to the 6th, x to the 4th. Then we'll put our y's in a final bracket, y to the 5th, y squared. Then we'll work out each of them separately as we've done before. We know a negative over a negative is a positive, and 6 goes into 24 4 times. Now we have the next part here. So we have the x's. So it's going to be, based on the quotient rule, 6 minus 4. And then we have y, 5 minus 2. And now we can finish it up. 4, x, 6 minus 4 is 2. And 5 minus 2 is 3, so that's going to be y to the 3rd. And that's our final answer.
In reviewing what we just did in example number 18 on the whiteboard, what I did was, just like I did on the whiteboard, I gathered up my coefficients, my x's and my y's, and worked out each one individually. I got 4x 6 minus 4, because that's a quotient, using the quotient rule. Here, using the quotient rule again. And I have 4x squared y cubed, and I just write that 4x squared y cubed. In example number 19, we have negative 35 c to the 18th d to the 12th divided by 5 c to the 10th d to the 7th. So here, let's work this out on the whiteboard in detail first.
In example number 19, we have negative 35c to the 18th, d to the 12th, divided by 5c to the 10th, d to the 7th. And as before, I'm going to put my numbers in one bracket and work that out. And then I'll put my c's in the next bracket. And then I'll put my d's in the last bracket. And then I'll work it out. So my first one here, I have negative 35 over positive 5. So 5 goes into negative 35. Well, a negative over a positive means it's negative. So we get negative 7 here. And then for the next part, we get C, 18, using our quotient rule, minus 10. And then we get D, 12, minus 7. And then we continue to get negative 7. 18 minus 10 gives us C8. And then 12 minus 7 will give us D to the 5th. And that's our final answer.
In summarizing example number 19 that we just did on the whiteboard, as usual, I gather together the coefficients, the like bases with the like bases, and then I go through here, just the regular division, and here, applying the quotient rule, I get, finally, negative 7c to the 8th, d to the 5th. In example number 20, we have negative 100x to the 14th, y to the 20th, z to the 30th, divided by negative 20x to the 7th, y to the 10th, z to the 15th. So now again, let's go over to the whiteboard and work this out in detail.
In example number 20, I have negative 100 x to the 14, y to the 20, z to the 30, over negative 20, x to the 7th, y to the 10th, z to the 15th. And as usual, I'm going to organize it in brackets. In my numbers, I put in one bracket. And then I'll put my x's in the next bracket. I'll put my y's in the next bracket. And finally, my z's in the last bracket, 30. And there I have that. Then I will do my division here. Well, a negative and a negative over a negative is a positive. And 20 goes into 100 5 times. Then I will use my quotient rule. X to the 14 minus 7. And then for my y's, y to the 20 minus 15. I mean 10. And then z to the 30 minus 15. Be careful there. That is to the 10. And then I get 5. X, well, 14 minus 7 is 7. And then I get 20 minus 10 is 10. And then I get 30 minus 15. And there we have z to the 15 power. And I just write it 5x to the 7, y to the 10th, z to the 15th, and that's my final answer.
Summarizing example number 20, as before, I collected up the coefficients, my x's, my y's, and my z's, and worked each one out separately to get my final answer, 5x to the 7th, y to the 10th, z to the 15th, just like I did on the whiteboard. In example number 21, we're asked to simplify negative 5x cubed, y to the 4th, times 4x squared, y, and all this divided by 10x to the 4th, y squared. Let's work this out on the whiteboard in detail to see how it is done.
In example number 21, I have 3 sets of monomials, negative 5x cubed, y to the 4th, and that's multiplied by 4x squared, y, and then we divide that by one more monomial, 10x to the 4th, y squared. I'll put that in brackets. So 1, 2, 3 monomials here. But we go about this the same way, because here we have, probably we'll have to use the product rule and the quotient rule to complete this one. So again, I'll put together a bracket with all my numbers in it. So I have negative 5 times 4 divided by 10. And then I'll take all my x's. I have an x here, I have an x here and bottom there. So an x cubed times x squared, and then it's divided by x to the 4th. Then I'll do my y's. I have a y to the 4th here. I have a y here, and I have a y squared here. And here I'll do my multiplication on top. So negative 5 times positive 4 is negative 20 divided by 10. So I'll do my product rules first. So I have x3, 2. So I add those up. So that means I get x to the 5th over x to the 4th. And I have 4 plus 1. So I'll have y to the 5th over y squared. Now I'll use my, negative 10 divided by negative 20 divided by positive 10 will give me negative 2. And then for this one, I use my quotient rule. 5 minus 4 will give me just x. And then 5 minus 2, and that will give me y to the 3rd. And that's my final answer.
In reviewing what we just did on the whiteboard, we see that we get putting together all the coefficients, negative 2, and then we put the x's in the next bracket, the y's in the y bracket, and work each one of these out separately till we finally get negative 2xy cubed. Welcome to part 3 of exponents, and here we're going to discuss the power rule amongst a few other smaller rules. So the power rule 3a, if we have the same base, we multiply the exponents. For example, we have a, r, s, so that means we have r times s because we brought this to the power, and then here our base is the same. So for example, if we have 3 squared and then we cube it, so we have 3 squared times 3 squared times 3 squared, which is what cubing means. That means As before, we learned if we multiply, we add them up. So it's 2 plus 2 plus 2, which is 3 times 2, which is 3 times 6, 3 to the 6th, so which is the same thing as 2 times 3. Now here, using the variable x, we go through the same process, and we see that we get x to the 6th, just as we would if we expanded it out and added it. So when you take a power to a power, you multiply the exponents. Another aspect of the power rule is if we have anything inside the bracket. So here, when we have the power outside of the bracket, we have to bring the power inside everything that's inside the bracket. In this case, we have inside the bracket x and y, so that means we have x to the n, y to the n. And showing an example of how this works, so if we have 4 times 3 squared, well, that's the same thing as 4 times 3 times 4 times 3. I just remove the brackets and rearrange it and put the 4's together and the 3's together, and that's the same thing as 4 squared times 3 squared, and then I worked it out in detail. 4 squared is 16, 3 squared is 9, and that's how I got 144. Now, if I do that with variables, it's the same idea. So instead of numbers, I used x and y squared. I bracketed them x times y times x times y, and then I rearranged the x's, I rearranged the y's, and that was the same thing as x squared, y squared. So when you take a power of a product, you apply the exponents to all of the factors of the product. And in C, when we have the power rule to the quotient, it's the same idea. We want to apply the exponent to all the parts of the quotient. So that means if we have a over b inside a bracket, remember this is inside the bracket, and we have the r out here, we bring the r here and here. Here is why it's true, so this is just an abstract version, r factors, and a over r, b over r. So when you take a power of a quotient, you apply the exponents to all the parts of the quotient, not just one, not just the top, not just the bottom, but all the parts. And you want to make sure that the bracket is covering the whole thing. So it's whatever inside the bracket is what that exponent is affecting, or that power is affecting. Now let's look at some examples. In example number 22, we have x to the 9th power. That whole thing, everything inside the brackets, is to the 4th power. So we use our power rule. We multiply 9 times 4, and we keep the x, and that's how we get x to the 36. In example number 23, we have a to the 4th, b to the 3rd, and this entire thing, and that's what the bracket is telling you, that entire thing is being brought to the 5th power. That means the 5 will be multiplied by the 4 from the a, and the 5 will be multiplied by the 3 from the b. The power rule tells us that it's a to the 4 times 5, b to the 3 times 5, and that's how we get a to the 20th, b to the 15th. In example number 24, as you see, this is a little bit more complicated. So what I'm going to do is I'm going to go to the whiteboard and work this out in detail to give you an idea and show you one way that you can approach this problem.
So in number 24, we have a cubed b over c to the 6th to 3. So we see that all of these bases are different. So the only thing we really have to do here is apply the product rule. And that means we're going to take this cubed and we're going to multiply it by everything that's inside there, like this. So we have a 3 times 3, B, well, since B is to the first power, it's going to be B times 3. And then finally, C, 6 times 3. So you have to do it to everything that's inside the bracket. So this power is affecting all of these. So now I'll continue. A to the 3 times 3, well, that's going to be A to the 9th. B, 1 times 3 is 3. And finally, 6 times 3 will give me C to the 18th. And that's my final answer for this one.
In reviewing 24, based on what we did on the whiteboard, here we have, as you see, I brought this 3 inside the brackets into everything, both the A, B, and the C, because all of those are inside the bracket that is brought to the third power. And then I did what I usually do. Here I have 3 times 3 is 9, 1 times 3 is 3, 6 times 3 is 18, and there's nothing else I can do, so I'm finished simplifying that particular example. In example number 25, we have now something with a negative coefficient and it's inside the bracket. So let's go to the whiteboard and see how I would work this particular example out.
In number 25, we have negative 2, x to the 3rd, z to the 7th, and cubed. So again, we're going to just we only really need to apply the power rule to this. So I'll do my numbers first. Negative 2 to the 3rd. And then I have my x, and I multiply 3 times 3. And my y, z, 7 times 3. So here I have negative 2 to the 3rd, so that means negative 2 times negative 2 times negative 2. So that means here we have negative 2 times negative 2 will give me positive 4, and then positive 4 times negative 2 will give me negative 8. Now for my x term, well, I have 3 times 3. So that means I will get x to the 9th. And then my final z term, or the z part, I'll have 7 times 3. And 7 times 3 will give me 21. And this will be my final answer.
In reviewing what we just did on the whiteboard in example number 25, so here I have the negative 2 to the 3rd power, then I did the x's, the z's, all of these to the 3rd power, and then I worked each one of these out. Remember, negative 2 times negative 2 is positive 4, and then positive 4 times negative 2 will give us the negative 8. And then, of course, the x is 3 times 3 is 9, and the z is 7 times 3, which is 21. In example number 26, here we have something a bit more complicated, so I'm going to work this out on the whiteboard for you.
In example number 26, we have 2q to the 0 power, s to the 4th power, over 5, q to the 9th power, s, and all this entire thing, everything that's inside there is raised to the fourth power. So what I'm going to do is what I usually do is I'm going to put my constants or my numbers, my variable, my q's, and my s's in different brackets and bring them all to the fourth power. So I start out with my 2 over 5, and I'll put that to the fourth power. And then I have my q0 and my q to the ninth, and I'll put that to the fourth power. And then I'll put my s to the fourth and s, and I'll put that to the fourth power. So I'll work out each one again separately. So I will use my power rules to do this. So I have 2 to the fourth over 5 to the fourth. And then I have, for my q's, I have q 0 times 4 over q 9 times 4. And then I do the same thing for my s's, s times 4, 4 times 4 over s to the 1 times 4. And now I work it through. So I have 2 to the 4, that gives me 16. And on the bottom, if I worked out 5 to the fourth power, it turns out that that's 625. And then, well, q to the 0, well, that's 0 times 4 is 0. And remember what I said, that anything to the 0 power is equal to 1. So that's just going to be 1 over q to the 36. And then for my last part, I have my s's, and I have my s. 4 times 4 is 16. And then s, 1 times 4 is 4, s to the fourth. And then I worked it out, to further work it out, so I have my 16 over my 625, and then I have my 1 over q to the 36, and here I have 16 s to the 16, s to the 4, so that's going to be s to the 16 minus 4. So finally I'll get, in the end, I'll get 16 over 625 times 1 over q to the 36, and then times s to the 12th, and then I can rewrite it all together, 16s to the 12th all over 625 q to the 36, and then I am done.
In reviewing what we just did on the whiteboard in number 26, so here I put everything. I brought the power out that's outside here and brought it inside and took everything to that power by multiplication. Now remember, 0 times 4 is 0. And remember what anything to the 0 power is. So when I just worked all this out, 5 to the 4th power, etc., and this was my final answer. So then there are some other properties of exponents, and these are things that you really should know when you're working out problems or examples that are a little bit more complicated because this stuff comes up. So remember, any single number or variable is always to the first power, meaning that if we have just x all by itself, that assumes that's to the first power. So for example, 3 is really 3 to the first power, or a is really a to the first power. And in the case of 2x, well, 2 is to the first power, x is to the first power, and that means we can look at it as 2x bracket 1 to the first power, where everything is brought to the first power. Anything to the 0 power is equal to 1, no matter what. For example, when we had situations, here x over n divided by x over n is n minus n is equal to 0. That gives us x to the 0 power. However you get there, anything to the 0 power is equal to 1. Welcome to part 4 of exponents. In this part, we're going to discuss about negative exponents and how you make negative exponents into positive and the process in which you do that. Because often what one is asked is to put everything in terms of positive exponents, so we want to figure out what happens when you get a negative exponent. How do you make that positive? We want to rewrite expressions without negative exponents. The first thing we do is we write the reciprocal of the base and then change the exponent to a positive to keep it with the original base. Now, of course, one may ask, what does this mean? Well, this is what it means. If you have a negative exponent, what it means is that essentially it's 1 over the base to the positive power. And in this case, the power here, negative 1, its positive power would be 1, so it's 1 over x to the first power, or 1 over x. And of course you can do the reverse. If you have a negative exponent on the bottom here, x to the negative 1, you can bring that upstairs and put that just simply as x to the positive 1, or just x. So let's look at a few examples. So for example, if we have b to the negative 7, what we want to do is we want to write the reciprocal of it and its positive exponents. So that means we'll write a 1 over b to the positive 7. In number 28, here we'll use this rule because we have 1 over y to the negative 8. So we'll bring the y upstairs and then change it to a positive exponent, giving us y to the 8. So in 27, we used this rule here, and in 28, we use this rule here. Evaluating negative exponents. So we want to divide and write without negative exponents. So let's look at a few of these. So in number 29, we have 4 to the negative 3. So since we have 4 to the negative 3, we want to put that as a positive, so we're going to write the reciprocal and then its positive exponent. That means we're going to write it 1 over 4 to the positive 3. And then, of course, evaluating that, 4 times 4 is 16, and then 16 times 4 is 64. In number 30, here we have that situation that we had before, that if we have 5 minus 7, well, 5 minus 7 using our quotient rule will give us a negative exponent of y to the negative 2. So there we have that, y to the negative 2. But now we have to convert that y to the negative 2 to a positive exponent. We have to take the reciprocal 1 over y and then 2 we have. In number 31, we have something a bit more complicated. So what I'm going to do is I'm going to work this out on the whiteboard in detail.
In example number 31, we have n to the fourth, in example number 31, we have m to the fourth, n to the negative 5 over p to the negative 2. Now we see that we have negative exponents for the n to the negative 5 and the p to the negative 2. And this we do not want. We want to make them into positive exponents. So here we're going to use our negative exponent rules. So the m to the fourth is okay, and we keep that the same. But the p to the negative 2, we're going to use the rule 1 over x to the negative y is equal to x to the y. So I'm going to move the p up here and make it p squared. Similarly, I'm going to take the n to the negative 5, and I'm going to use the negative exponent rule that says x to the negative y is equal to 1 over xy. So that means that I'm going to bring the n to the negative 5 to the bottom and make that to the positive 5.
In summarizing number 31, we have m to the fourth. I put this downstairs as n to the fifth power, and I brought p to the negative 2 upstairs as p squared. In number 32, we have 2 over 5, and the whole thing is to negative 3. Well, I'm going to work this out on the whiteboard also.
In example number 32, I have 2 over 5 to the negative 3. Now here I have the negative exponent outside of a bracket, and inside the bracket is a quotient. Well, this is the same thing because we have to make the negative 3 affect both the top and the bottom. So this is the same thing as 2 to the negative 3 and 5 to the negative 3. And again, we're going to use our negative exponent rules. So recall that x to the negative y is equal to 1 over x to the y, and that 1 over x to the negative y is equal to x to the y. So this is the same thing as saying we're going to take the 2 to the negative 3 and move that downstairs. So that's going to be equal to 1 over 2 to the 3, and then the x to the 5 to the negative 3, I'm going to move that upstairs and make that 5 to the third. And I'll just put a 1 as a place mark to show you exactly what's going on. And then I'm going to do 1 times 5 to the third. So I have 5 to the third, and then 2 to the third times 1, and then I get 2 to the third. But if you notice, it's really the same thing as flipping over the stuff inside the bracket and then making that positive. So as a shortcut, what I can do, I can start out 2 to the fifth to the negative 3, and that would be the same thing as 5 over 2 to the positive 3. Either way you look at it, it's fine, because in the end, we will get 5 to the third, 2 to the third, and in both cases, we have 5 to the third, and that's going to be equal to 125, and then 2 to the third, that's going to be equal to 2 to the third, that's going to be equal to 8. Similarly here, we have 5 to the third because that's 5 times 5 times 5, and that'll be 125. And then at the bottom here, we will get 2 to the third, which is 2 times 2 times 2, which is 8. So either way you look at it, you'll get the same answer.
In summarizing 32, we end up with, to get everything positive, it turns out that we get 5 cubed on the top and 2 cubed on the bottom, and that will give us 125 over 8. For number 33, we have 3a to the fourth over 4, and this whole thing is put to the negative 2 power. So let me work that out on the whiteboard to show you how this could be done.
We're given 3a to the fourth power divided by 4. And this whole thing is to the negative 2 power. Now, the first way I can do this is just multiply everything inside the bracket by negative 2. So I get 3 to the negative 2, a to the 4 times negative 2 because it's a power. And then I have 4 to the negative 2. And this is equal to 3 to the negative 2. A to the 4 times negative 2 is to the negative 8. And then 4 to the negative 2. But I have all these negative powers. So now I have to use my negative quotient rule to get them to be positive powers. So that means that the 3 to the negative 2 will have to go downstairs and become 3 squared. The a to the negative 8 will have to go downstairs and become a to the 8th. And the 4 to the negative 2 will have to go upstairs and become 4 squared. And now I just work it all out. So the top becomes 16 and 3 squared is 9. And then I get a to the 8th. A to the 8th. Now the other way I can do it with a little bit of shortcut, seeing that I have a quotient inside the bracket and I have a negative exponent on the outside, I have a to the fourth, 4, and that's going to be equal to, to the negative 2, and now what I can do is say 4 over 3a to the fourth, and now it's to a positive 2. And then I could say 4 squared over 3 squared a to the fourth times 2. And again, I'll get on the top 16. And this will be 9, and this will be a to the 8th. So either way, whether I do it by bringing the exponent inside the bracket or by flipping the quotient over, will give me the same answer.
Summarizing 33, whatever technique you use, you'll end up with all positive exponents. So this way I did it all positive exponents by turning it upside down and then bringing the 2 inside. And then working it out explicitly, so I get 16 over 9a to the 8th. In number 34, I have this, and again, what I'm going to do is I'm going to work this particular example out on the whiteboard to show you how it could be done.
In example number 34, we have 3a to the 6th b to the negative 4 over 2 c to the negative 2. And all of this is to the second power. Well, my strategy here, and of course you can just multiply it in and work it out the long way, but I'm going to make a strategy here. And I see I have these negative powers inside my bracket. So I want to get rid of the negative powers inside here. So I'm going to use my negative quotient rule to do this. So that means I'm going to bring my b to the negative 4 downstairs and make that b to the positive 4. And then I'm going to take my c to the negative 2, move that upstairs, and make that c to the positive 2. So now let me do that. So I'll get 3a to the 6th, which I do not touch. I'll bring my c to the negative 2 upstairs and make that positive c to the positive 2 power. I'll leave my 2 alone here, but I will bring my b downstairs and make that to the positive 4 power, and then I will square it. And now I will proceed to organize and bring everything in. So I now have 3 squared a to the 6 times 2, c to the 2 times 2, all over 2 squared b to the 4 times 2. So now I'll just work out the rest of it. So 3 squared is 9. A, 6 times 2. Well, 6 times 2 is 12. So that's a to the 12. C to the 2 times 2. Well, 2 times 2 is 4. And then on the bottom, I have 2 squared. Well, that'll give me 4. And then b is the 4 times 2, and that'll give me b to the 8th. And since all these bases are different, and there's nothing I can simplify this with, so then I am done, and this is as simplified as I could make this particular expression.
Summarizing 34, we have here everything in this case was put in terms of its positive exponents inside the brackets. So the b was put downstairs as b to the 4th. The c negative 2 was put upstairs as c squared. And then everything was multiplied through using the power rule to get our final answer. In example number 35, we have 10x cubed, and this is to the negative 3rd power. So here again, I'm going to work this out on the whiteboard.
In example number 35, I have 10 to the x cubed to the negative 3. Now here again, I'm going to use my negative exponent rule, and that will tell me that one way to look at it is 10 to the 3, x to the 3 times negative 3, and that'll give me 10 to the negative 3, x to the negative 9, but because these are negatives, that means I'll have to put 1 over 10 to the 3rd here times 1 over x to the 9 here. And 10 to the 3rd, well, that's 1 over 1,000 times 1 over x to the 9. And then I'll just put it together and write 1,000 x to the 9. Another way to do this, as I showed before, is to recognize, again with the exponent rules, 10 to the x cubed negative 3, that I can just make that positive by recognizing that this really is something over 1, so that if I turn it over, I'll get 10x cubed, and this will be to the third, and then I will continue. So 1 to the third is just 1, 10 to the third, x to the 3 times 3. So here again, I'll get 1,000 x to the ninth. So again, either way you look at it, you'll still be using the negative quotient rules, and you'll get the same answer.
Summarizing example number 35, in order for me to get it as a positive exponent, I had to put 1 over 10x to the third, and then here I have the positive 3 rather than to a negative 3, and then worked it out to get rid of the exponent using the power rule, where 1 to the third power is 1, and then 10 to the third power is 1,000, and of course using the power rule right here, where we have x, 3 times 3 will give me x to the ninth. In number 36, I have this to the negative 2 power, and I'm going to work this out on the whiteboard.
In example number 36, we have 9a to the fourth, b to the sixth, divided by c to the third. And that's to the negative 2 power. And we see that inside the bracket here, they're all the exponents are positive, so we don't really have to do anything. So all we have to do is either multiply the negative 2 in and then use our quotient rules, or we can just realize that we can flip it over and change this to a positive, and that's another way of using the quotient rule. So I'll do just changing it by flipping over. So we're going to get c to the third over 9a to the fourth, b to the sixth, to the second power. So you see, this is a negative 2, this is a positive 2, but you see now the c cubed is on top rather than bottom, and this part is on the bottom rather than the top, but now the exponent outside the bracket is positive. So now I'm going to multiply the 2 inside the bracket. So I'm going to go c to the 3 times 2 over 9 squared, a to the 4 times 2, b to the 6 times 2, and that's going to be equal to c, 3 times 2 is 6, so it'll be c to the 6, and that's going to be divided by 9 squared. That will give me 81. And then 4 times 2 is 8, so it's a to the 8th. And then b, 2 times 6 is 12, so that'll give me b to the 12th. There's no more simplification I can do since all these bases are different, and I am now finished simplifying this particular example.
In summarizing example number 36, I ended up here. I just flipped it over inside the bracket and turned this one into a positive exponent. As I said, this was one of the techniques, and then worked it through to get my final answer. In number 37, I have here a lot of negative exponents inside the bracket, and I also have a negative exponent outside the bracket. So let us work this out on the whiteboard to see how we could simplify this particular expression.
In example number 37, we have 7a to the negative 6, b to the negative 2, all divided by 8c squared, and the whole thing is to the negative 2 power. Now, of course, there are different ways we can go about this. One way is to multiply in the negative 2 first, and that will give us 7 to the negative 2, a to the negative 6, negative 2, b to the negative 2, negative 2, divided by 8 to the negative 2, c to the negative 2 times negative 2. And there we have 7 to the negative 2. A negative 6 times negative 2 will give us positive 12. B to the negative 2 to the negative 2 will give us b to the 4th. And then on the bottom here, we have 8 to the negative 2, and then c to the negative 2 times negative 2 is negative 4. So now we have to start getting rid of those negative signs using our negative quotient rule. So we'll have to bring the 7 downstairs. So we'll have 7 squared. The a to the 12, well, that's okay. The b to the 4th, that's okay. Now let's look down here. Well, we have that a, 8 to the negative 2. Well, that's not good. We'll have to bring that upstairs, and 8 squared. And then we have that c to the negative 4. So we're going to have to bring that upstairs and make that c to the positive 4. And then, of course, we'll just finish up by taking the squares. 8 squared is 64. And we have a to the 12th, b to the 4th, c to the 4th, all over 49. Now, of course, the other way we can do that is to flip this inside the bracket first and change this to a positive sign and then continue. So let's do it in a different order. Now, the other way I can do 37, I can actually approach it in this way. I can have 7a to the negative 6, b to the negative 2, all over 8c squared, and there we have to the negative 2. So what I'll do is I'll just change the position inside the quotient and make this positive. So what that means is that I'll have 8c squared over 7a to the negative 6, b to the negative 2, and that'll be positive. Notice how these still remain negative inside there. The only thing I did was change this negative sign to positive by flipping this over. Then I again will use my power rule, and I will go 8 squared c 2 times 2 divided by 7 squared a to the negative 6 times 2, b to the negative 2 times 2, and that I will get 8 squared c to the 4th over 7 squared. Well, as you see, we have 6 times 2, negative 6 times 2, and that will give us negative 12. So that's a to the negative 12. And then we have b to the negative 2 times 2, and that's b to the negative 4. Now we have to use our negative quotient rules to bring that upstairs. So that means we have 8 squared c to the 4th, a to the 12th, b to the 4th, and that will be over 7 squared. And I'll just rearrange it and finish it off a bit. So I have 64 a to the 12th, b to the 4th, c to the 4th, and this whole thing is over 49. And this is the same as we got in the other approach. So either approach is fine. Some strategies are shorter, some strategies are longer. Whatever works for you would be fine.
Summarizing 37. Here what I did is that I got rid of all the negative exponents inside the bracket. In this particular way of doing it, as I showed, there are different ways of approaching this. And then I did change the sign of the power and multiplied in using the power rule. In example number 38, we have this inside the bracket and it's just squared. So what I'm going to do is work this out on the whiteboard.
In example number 38, we have negative 6m to the 4th n to the negative 7 divided by 5m squared n to the 15th. All this to the positive 2 power. So since we have this quotient inside here, and it's to the positive 2 power, we don't even have to worry about flipping it over or doing anything fancy because we have a positive quotient. But if we notice, we have negative powers inside there. But also note we have a negative 6. But a negative 6 is just a negative number, so we leave that alone. So the only thing we have to do is, based on our quotient rule, is to move our negative n to the negative 7 to the bottom and make that 1 over n to the positive 7, and then deal with our power outside the bracket. So here's what we do. Negative 6m to the 4th. Nothing on the bottom here is negative, over 5m squared n 15. And then I'm going to bring down the n and make that to the positive 7. And now I will square it. So now I'll just organize everything. So I'll put my numbers in my first bracket, n6 over 5 squared. And then I'll put my m's, m to the 4th over m squared, and I'll square that. And then finally, I'll put my n's, and remember, it's over 1 because this is on the bottom, and therefore there's a 1 over there, times 1, so that's going to be n to the 15, n to the 7th squared. So now I'll work that through. So that's going to be equal to -6 squared over 5 squared. And then my m's, so I'm going to bring my 2 in there. So I'm going to have here m to the 4th times 2 over m squared times 2. And then here I will have, well, 1 times 2, 1 to the 2 power is just 1. So that will remain the same. And then the bottom, I'll use my product rule, n to the 15 times 2, n to the 7 times 2. So here on top, I will get negative times a -6 is a positive 36, divided by 5 squared is 25. Then I will get m to the 4 times 2, so that's going to be m to the 8th divided by m to the 4th. So I'll just put in brackets to keep it separated. And then I will get 1 over n to the 30th, because 15 times 2 is 30. And then n to the 7 times 2, well, that's 14. And then I will continue using my various rules. So here I have 36 divided by 25, and then I use my quotient rule, 8 minus 4, and then here I'll just keep the 1 on top, and I'll just use my product rule here, n to the 30 plus 14, and continue on. 36 over 25, so n to the 8 minus 4, so that's going to be m to the 4, and then on the bottom times 1 over n to the 44, and I'll put it all together in one quotient situation. 36 m to the 4th over 25 n to the 44. And now I have simplified this very complicated expression to this not as complicated expression in example number 28.
Summarizing what we did on the whiteboard. So in this case, I made sure what I did here is I made sure I got rid of all the negative exponents inside the bracket and then worked it out till I got my final answer. In example number 39, we have this, and it's to a -4th power. So what I'm going to do is work it out on the whiteboard.
In example number 39, we have 3y to the -3 divided by 2x squared, and this whole thing is to the -4. So what I'm going to do is I'm going to get rid of the negative number inside the bracket. So here, so as you recall, our quotient rule will say that we have y to the -3, and that is going to be 1 over y to the 3. So I'm going to now rewrite this as 3 over 2x squared y cubed, and this whole thing is to the negative fourth power. Now, as I said before, if you see a negative power outside of a quotient, that gives you permission to just flip it over and make it positive. So I'm just going to do it that way. Of course, there are other ways to do it, and all those other ways are fine so long as you get the correct answer. So I'm going to go 2x squared y cubed all over 3, and I'll do this to the fourth power. And now I'm going to continue simplifying as usual. So I have 2 to the third, 2 over 3, I mean, to the fourth power. And I have my x's, and I have, so here I have x squared times 4, and then I have my y to the third times 4, and then I'll finish it up, 2 to the fourth over 3 to the fourth, and that's going to give me x to the, and then x to the 8th, y to the 12th, and then I'll work this out, and it turns out 2 to the 4th. Well, 2 to the 4th is 2 times 2 times 2 times 2, so that's 4, so that's 16, so I'm going to get here 16 on top, and then on the bottom I'll do 3 times 3 times 3 times 3, so here 3 times 3 is 9, 3 times 3 is 9, and 9, and that's going to be 81. So on the bottom I get 81, and then x to the 8th, y to the 12th. And now I am finished simplifying this particular example. Notice all positive exponents. There are no negative exponents because recall we do not want any negative exponents.
Summarizing example number 39, what I did was here is I got rid of the negative exponents inside the bracket, and then I flipped it over and worked it out. In number 40, we have this. Now notice here how the bracket, this is to the negative 2, and it's only this. It's not the entire quotient. And this bottom one, where this one is to negative 4. So you have to look at it a little bit different than we did here, where this bracket covers everything, and this bracket only covers the top to the negative 2 power, and this bracket only covers the bottom to the negative 4 power. So let's look at how we deal with something like this on the whiteboard.
In example number 40, we have x squared, y to the negative 3, z to the negative 2, and this whole thing is to the negative 2 power. Then on the bottom, we have x cubed, y squared, z to the negative 1, and this whole thing is to the negative fourth power. Now, notice that the bracketed negative 2 and the bracketed negative 4 don't have a quotient inside. This bracket, everything's multiplication. This bracket, everything's multiplication. So we can't just flip it over. We really have to work out everything. And actually, the first thing we're going to do in this particular one is I'm going to now I can bring in the -2, or I can switch places, but I have to be very careful when I switch places. So I can't just do it the way I did a regular quotient. I have to be careful of these powers. So what I can do is bring this whole thing upstairs and this whole thing downstairs using my negative quotient, my negative power quotient rules. So what I can do now is say x cubed y squared z -1, and then bring that to the fourth power. Notice how I brought that upstairs. And then on the bottom, I can go x squared y to the -3, z to the -2, and this is to the +2. So in a way, I flipped it over, but it's slightly different than when I do it when the whole thing or the whole expression is inside a bracket where the quotient is inside the entire bracket. So now what I'm going to do is I'm now going to use my power rules. So I'm going to get x to the 4th times 3, and then y to the 4th times 2, and then z to the -1 times 4. And that's what I have on top. And similarly, I'll do for the bottom. So I have x 2 times 2, because I'm bringing a +2 in there, and then y to the 2 times -3, and then z to the 2 times -2. And then I'll work out each of these, and then I'll sort out the negative signs at the end. So here I have x to the 12th, y to the 8th, z to the -4, divided by x to the 4, y to the -6, and z to the -4. Now I'll just organize them, and I'll do the x's, x as I've done before, and then my y's, and then my z's, so I have now, do each one separately, so I have x to the 12 minus 4, and I have y to the 8 minus -6. Notice how I'm very careful of my signings because it's a quotient. And then I have z to the 4 z to the -4 minus -4. So I have here 12 minus 4 is 8. And for x to the 8. And then I have y 8 plus 6. And then finally I have z negative 4 plus 4. And then I have x to the 8th. 8 plus 6 gives me 14. So that's y to the 14. And recall z, negative 4 plus 4 is 0. And remember, anything to the 0 power is 1. So that means we have x to the 8, y to the 14, and then times 1. Because anything to the 0 power is 1. So there we just rewrite it, x to the 8th, and y to the 14th. And now we are finished simplifying this really complicated expression into something that truly is rather simple.
Summarizing example number 40. So here, as you noticed, in this case, I did the negative exponents first, taking this entire expression and putting it on the bottom, and making it positive, and taking this entire expression here and putting it on top and making it positive. And then I continued working it out the way I would just a regular expression where this is brought to a power and this whole thing is to a power, using my power rules. And then finally here I have still negative things going on, but now I can start moving things up and down between the numerator and the denominator, or I can just use my quotient rules to work that out. However you want to do it is fine. Thank you very much. I hope you enjoyed this video. Be well, take care, and goodbye for now.